All right, I'm going to jump right into this one. This is the 2018 number 5, pretty similar to the 2017 number 6 I did a moment ago. Let's just kind of see how this thing plays out. So here we go. So we've got some function f. Now I do think they kind of made a little bit of a correction from the 2017 to the 2018. I think they found out that 2017 was a pretty tough question. So they're asking a very, very similar concept, but they really strip down the question. So you'll notice we don't have an interplay of 3 different things. I think that just probably was pretty darn confusing. And so they made this one a little bit more straightforward most of the way through. So they're asking us for an average rate of change. So the average rate of change, of course, is just finding the average slope. So it should be f of pi minus f of 0 over pi minus 0. Now that is asking us to remember a little bit of stuff from the unit circle, and I'm going to actually be referring to this a couple of times. So remember, here is 0, which is the coordinate 0, 1. And here is pi over here, which is the coordinate negative 1, 0. We've got 0, 1 up here at pi over 2, and 0, negative 1 at 3 pi over 2. And we're going to be using those. And if you recall back from analysis, anything in this quadrant was positive. Only the sign was positive out here. Everybody's negative except for the tangent in this thing, and the cosine is positive down here. Those are going to actually come into play at one point in time in this problem. So if we want to know f of pi, we would take e to the pi cosine pi minus, and if I plug in 0, I get e to the 0 cosine of 0 all over pi. And very much like the problem we did a moment ago, you want to remember that e to the 0, of course, is 1. And the cosine of 0, of course, is 1. So this entire bank is just 1 times 1. And e to the pi is fine. It is what it is, but the cosine of pi is negative 1 all over pi. So kind of an obnoxious looking answer. I've got a negative e to the pi minus 1 over pi. Not an answer that a lot of students feel very, very comfortable with because it just looks kind of obnoxious, but that's what they were looking for. Now, if I want to find the slope of the tangent at 3 pi over 2, the first thing I need to know is what is the derivative at 3 pi over 2. So let's go ahead and find f prime. So we have e to the x cosine x, so we're just going to do a nice little product rule, but notice they actually made this one a lot nicer than that 2017 one, which was so tough. So we're going to take the derivative of the first times the second, so the derivative of e to the x is e to the x, so that's f prime g plus g prime. Oh, what's the derivative of the cosine is the negative sign. That's the one we sometimes forget about, that it was negative, times the first, which is e to the x, which it might be easier if we wrote this as e to the x times the cosine x minus sine x. Now, you do not have to factor that out, but it just looked easier to me if I did that. So if I'm looking at f prime of 3 pi over 2, I, of course, have e to the 3 pi over 2 right here. The cosine of 3 pi over 2, as indicated up here, the cosine of 3 pi over 2 was 0. And the sine of 3 pi over 2 is negative 1. So notice I've got 0 minus negative 1, which is just 1. And so that entire answer is e to the 3 pi over 2. And I hope you can see that that was actually a little bit of an easier problem than the one that we had been working on from the 2017 exam. Now, here's where the problem actually does have some teeth. They're again going to ask for the absolute minimum, which is actually a topic that we discussed on one of the previous concepts, that we always have to then check the endpoints as well as where the derivative changes from negative to positive. So keep in mind, if I want a minimum, I want it to go from negative to positive on its derivative. So we're going to go ahead and take a look back at what we had. So recall that we knew that f prime of x was e to the x times the cosine of x minus the sine of x. Well, the only way that that derivative could be 0, well, e to the x can't be 0, so I would need cosine of x minus the sine of x to be 0, or in other words, the cosine of x to be the sine of x. Well, on the unit circle, the only place where the sine and the cosine are the same is in the first quadrant, and the third quadrant, and the place where they're the same is in that isosceles triangle, the 45, 45, 90. So we're going to check pi over 4 as a possible answer, 5 pi over 4 as a possible answer, 0 as a possible answer because it's an endpoint, and 2 pi. So here we go. So let's go ahead and let's find out what is the absolute. I believe in this particular problem, we're looking for the absolute minimum of f. So let's figure out what is f of 0, what is f of pi over 4, what is f of 5 pi over 4, and what is f of 2 pi. And we should make a little note that we're going to check endpoints and where f prime of x is equal to 0. So f of 0, of course, now keep in mind that our function was e to the x. Let's see, what was that original function? That was e to the x cosine of x. I'm going to write that up here. F of x is e to the x cosine of x. So f of 0 would be e to the 0 cosine 0. E to the 0 is 1. The cosine of 0 is also 1. So it looks like I got, well, 1. Okay. E to the pi over 4 cosine pi over 4, which of course is e to the pi over 4 times root 2 over 2. What an ugly answer. I don't even know what that is. I hope that's not the right answer. And then I could do e to the 5 pi over 4 times the cosine of 5 pi over 4, but the cosine of 5 pi over 4 is negative root 2 over 2. And last but not least, e to the 2 pi, and the cosine of 2 pi is 1. Well, it's actually fairly nice that they asked for the minimum because these three values are all positive numbers, so that has to be the minimum. So 5 pi over 4 is the absolute minimum for x between 0 and 2 pi. I don't really have to justify that because it's the only one that is negative, because that's pretty dang clear that between positives and a negative, the negative is going to be the lowest on that particular totem pole. All right, and our last problem, and then we're done for this particular set of videos. G is some function. Now notice this is G prime. That's real tricky because they're saying something about G, but they're talking about this graph being G prime, and it's asking for this limit. So let's see. Let's see, what is the limit as x goes to pi over 2 of f of x over g of x? Well, when you look at f of x, which of course was e to the x cosine x, for some reason I have a hard time remembering that. As I get really super duper close to pi over 2, the cosine of pi over 2 is 0. So it appears that the top is going to 0, and the bottom, see, the limit as x goes to pi over 2 of f of x is 0. The limit as x goes to pi over 2 of g of x, they told us up here, was also 0. They said it was differentiable, and it went to this value, and since it was differentiable, the limit has to be that number. Well, hey, if you have a limit of two things that both go to 0, by L'Hopital's rule, remember that guy that looks like hospital, the limit as x approaches pi over 2 of f of x over g of x is the same as the limit as x goes to pi over 2 of f prime of x over g prime of x. Well, that actually makes life a little bit easier because as I get closer and closer to pi over 2 on g prime, which is the graph they gave me, this looks like g prime gets really, really close to the number 2 right there. That wasn't so bad. And then if I want to find out what happens as I get close to f prime at 2, well, let's go back here and see what happens if we look at f prime. What happens is I get really, really close to pi over 2. Well, e to the pi over 2 is what I have here. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So it appears to me that as I get really close to pi over 2, I'm going to get a negative 1 times e to the pi over 2. So that would be negative e to the pi over 2. Certainly not a very pretty answer, but that's the answer that comes directly off of that information, and we have now completed that particular question. And honestly, I've been doing these for a while today, and I'm tired. So I hope that was helpful to you, and I would love to know how you're doing. Please give me some feedback. Again, please try the new problem without looking first at the answers, and let me know how you're doing. Okay, please stay in touch. Bye-bye.